All right, so we're going to end this week by learning how to graph these gravity models, how to create a semi-accurate graph. Okay, so let's take this this problem here. The height of an object is launched off a very tall cliff can be modeled by this equation. Look, the initial velocity was 70 meters per second. And we actually already know the initial height, which is 1,055 meters. In fact, that's one of the extremely important things to know is the initial height, because it's also the y-intercept. So I'm going to make a graph down here, and I'm going to start by making a dot right there at the y-intercept at 1,055. But in order to graph this accurately, we should also figure out the vertex, and we should figure out when it lands. So that's going to take a couple steps. To find the vertex, we have to first complete the square. So I'm going to write I'm going to divide everything by -5 first. You always have to divide everything by -5 to get that to be a 1t. So that'll be minus 14t, because 70 divided by -5 is -14. And then minus 211. And then in order to keep completing the square, we have to do that part where we add half the b term squared. Half 14 is 7, and 7 times 7 is 49. And then we subtract it on the outside of that. But all of that's in brackets because it still needs to get multiplied by -5. Then this part here, the perfect square, factors to t minus 7 squared. And then 211 and 249 is -260. And then -5 gets multiplied through. So it would be -5 times t minus 7 squared. And -5 times -260 is positive 1,300. So now I know the vertex. The vertex is at 7, 1,300. So I'll go back to my graph. I know that at 7 seconds, it's at 1,300 meters in the sky. I also know, because parabolas are symmetrical, that if it took 7 seconds to get from 1,055 to 1,300, it will take 7 more seconds to get back down to 1,055. So I know that it's going to go through this point here at 14 seconds. It'll be back to 1,055 meters. So look, I've actually got a good portion of what I need to do to graph it. I just need to figure out where it lands. In order to do that, I need to find the 0. So I'm going to quickly do this now to keep the video brief. But to find the 0, I would just set this equal to 0, and I'd subtract 1,300, and then divide by -5, because that would move the 1,300 off, and divide by -5, and you'll get t minus 7 equals 260 again, and then or t minus 7 squared. And then when I take the square root, I get t minus 7 equals plus or minus, the square root of 260 is 16.1. Now, the negative doesn't matter, because again, the negative would be when it was down here somewhere before the rocket even launched, or the projectile even launched. So we're just going to use the positive in this case. And then finally, when you add 7 to each side, you get 23.1 seconds. That's the landing point, is at 23.1, 0, when it equals 0. So then I'll put that on my graph here at 23.1, and then I can just finish this by connecting like so. So I've got the vertex, the max